All right, so let's start. All right, so hello everyone. Welcome to today's session. You are listening to Amit. So maybe if it's not that visible, I can. I'm Amit. I have been in the industry for around 20 years now, and most of my life has been on DevOps and infrastructure management, or you can also call it sometimes as systems engineering. Right? So I've been working in the industry for quite some time now. And today we are going to talk about Docker. Right? So we will talk about containerization. What is containerization? Why do we need it? And how does Docker help in containerization for us? Okay. So let's quickly talk about a problem. And then we are going to talk about the solution, which is containerization and which is Docker. Is my voice not clear? Okay, hold on a sec. I know what could be the problem. Give me a second. How's the volume now? Is it better? Okay, is it comfortable? Can you understand me? To generate a distributable like a binary or something, right? So let's say you create a binary, which is let's say an dot jar. Let's say a jar file, right? Which is an executable on Java. Your code is in Java, and you write a jar file, or you compile it, and you get a jar file. And then what you do with the jar file? Right? Jar file is an executable which is of your product. Maybe you have a nice web application or you have a database or whatever, right? Jar file is your product. What do you do with the jar file? You give it to your customer, right? So you have a let's say customer, right? You have this customer and you give this jar to the customer, right? And you ask the customer that, hey, here's a jar file, execute it and use my product. Now, customer can try to execute the jar file, but then there could be some challenges. Like for example, what is the Java version to install, right? What environment variables to set? Okay, are there any specific operating system level considerations? Like, do we need some? Can we run it on Ubuntu, or can we run it on any Linux, or can we also run it on Windows? Right. So what is the environment in which this jar file can be run? Right. So the problem is with the environment, right? Customer gets the product, but they have to make sure that the environment is also set up correctly. And that is kind of a challenge. Okay. Another thing is, well, let's say you are a developer, right? You are a developer and you have written your code and you get a jar file and it works for you. Now you give your jar file to QE guy, let's say a testing team. right? Let's say you give your jar to testing, but testing team will say, it's not working for me, right? I cannot run this product. And why they can't run this product? Because of so many things. There maybe their machine is not compatible. They don't have the correct binaries installed. They don't have the dependencies. They don't have the correct environment variables. So the product is working in one person's machine, but it is not working in another person's machine. And it requires a lot of environmental setup to work on the customer's machine. So what's the solution? Right? Everybody aligns with the problem. What is the problem? Right? Cool. Okay. So that's the problem. The solution is rather than giving this jar file, we should be delivering the jar plus the environment. Okay. The environment could be binaries, dependent binaries, libraries, libraries, configurations, environment variables, etc. Okay. So you set up this whole thing and you deliver it along with your product. Okay. You make a big bundle out of it and you deliver this rather than delivering the yes. Right. So rather than just delivering your jar, you deliver this whole binary. Okay. And this binary is called such a binary. Come on, what did I do? Yes. Such a binary is called a Docker image or a container image. It looks like I am not well versed with this tool. Okay, so this is a Docker image, also known as sometimes as container image. Okay. And then you deliver this entire image to your customers, right? Or to your any other user of your product, maybe testing people, right? So rather than giving this, you give this entire image to the customer. And the customer can directly execute it and get their application running, right? So what happens is this container image is nothing but a bundle of your application plus anything required by your application to execute. So any dependent libraries, OS utilities, configurations, anything that is required is bundled within this image. And then this image is executed. It can be executed anywhere, wherever it is required. Okay. And the customer can then use this image and then run the application inside this image. Okay. Right. So this is what it is at a high level. Unfortunately, we can't go into much detail because we have very less time, but this is what it is. This is called containerization. Now, how do you deliver these images to the customer? Okay. So to deliver the images to the customer, you can either directly send them this image as um, as a zip file, as a tarball, right? This entire image with your application and everything together. But that's not a very convenient way. You don't deliver software like that, right? What you do is you can upload this image to a uh, we don't have other shapes here. Okay, so you can upload this image, container image, to an external service. Okay, this is a container image. You can upload it to an external service. Such an external service is called a container registry. Okay. Such an external service is called a container registry. Example, Docker Hub. You might have heard about Docker Hub. Okay. So whenever you produce a container image, you upload it to the registry. And from the registry, the customers can download that image and then consume it in their environment. Okay, so a registry is nothing but a service to share your container images, similar to GitHub to share your code, and YouTube to share your videos and all that, right? So what happens when the customer gets this image? When the customer gets this image, they can execute it. Okay, they can execute this image, and from this image, they can produce a running application. Their application can run. They get an isolated environment and the application can run. And the users can access this application from anywhere in the world, right? How you expose it. So maybe from via browser or HTTP, users can access this application. Or maybe this application is not supposed to be exposed externally. It's a local database, so you can do that. Or it just has a script. You can, do that. Okay. So I'm not going to show you how to create this container image. It's kind of an elaborate thing to do. But maybe in the next classes, I can talk about this. But I'm going to show you how you can consume the images. So how you can go to Docker Hub and look for the images and then use them. Okay. So for that, let's go to Docker Hub. So if I go here, this is Docker Hub, and this is a registry to share and collaborate on images. Okay. Now, how do I find images? So you can click on search, Docker Hub. There also used to be, I don't know if it is this one, not this one. Okay, there used to be okay, yeah, cool. So this is Docker Hub. You can search for any image if you are looking for it, or if you want to look for the popular images, then if you scroll down, you will see so many popular images for different categories. Right? You have Memcached, Nginx, BusyBox, Alpine, so many things here. Okay, so I'm going to show you something called as Jenkins. Okay, I'm not sure if you have heard of Jenkins, but Jenkins is a orchestrator tool which is used for creating your CI and CD pipelines. Okay, so if I search for Jenkins, you can see here, this is Jenkins image. And this is also a Jenkins image. This is also a Jenkins image, right? So there are multiple images with name Jenkins, and there are some different flavors of other namings as well. So I'll come back to that, what these different namings mean. Okay. But let's start with this one. Okay, Jenkins. So here, now, hold on a second. Let's come to here. Okay, so this is the Jenkins image, Jenkins container image. That means just by looking at it, I can understand that this application or this container image will contain Jenkins and the complete environment to run Jenkins for me, right? That means if I download this container image, let's go back here. Somebody has produced this container image and uploaded it into Docker Hub. If I download this image and execute it, I will get my Jenkins app. I don't have to do anything else. I don't have to set up any environment. I don't have to set up any binaries, do any configurations. I don't have to do anything. I can just download this and run it. That's what my understanding is looking at it. Maybe I should make it light theme. Yeah. So that's what I understand. So you can see the documentation here and look around, read more about it. But what I'm going to do is I'm going to use this. So now I'm going to act as a consumer of an image and use it. Okay. So how do we use it? Well, for using any container image, we need to have a operating system. It is on top of operating system that you will run this. So I already have a lab machine, which I'm going to launch and connect to. And I hope my audio is still okay. All right, hopefully you can see my terminal. I zoom in a bit. Okay. Okay, so this is an instance which I created on AWS, but it does not matter where it is. Okay, nothing is related to AWS here. It's just that I have this host here, which has some CPU, some RAM, but I'm going to run my containers on it. Okay. So the first thing that I need to have to able to run my container is the capability on this machine to run the containers. That means I need to install Docker. Okay, be able to run Docker containers. I need to install Docker. How do we install Docker? If I just look at it, Docker install Ubuntu. It's an Ubuntu based machine, so I just look for that. And here the uh, installation guide. Okay. So first is I'm going to add an app repository for Docker. If you are not familiar with Docker, after the class, you can maybe look more about it, what I did by watching the video. But it's just that I'm adding one more location to download the installation packages, which is for the Docker location. But it is doing whatever it is supposed to. And then we are going to install it with this command. Done. So this is done here. Okay. Now, if I run Docker here, I should get some output. Okay. Right. So now Docker is installed. What I'm going to do is I need to use this image. Okay. So what I'm going to do is I can pull this image. I can pull this image into my machine. Maybe I should do this. Yes. So I can pull this image into my machine and then use it. So the command to pull a container image from registry to here is Docker pull and the name of the image. This is the image here. Okay. If you scroll down, you will also see the same command suggested here, Docker pull and then Jenkins. Okay. So I'm going to use this command. Okay. One thing is all the Docker commands have to be run with sudo permissions. Okay. I need to run Docker commands with root permissions. That is a limitation of Docker. right? So now if I say Docker images, I can see, as I said, all commands should be sudo. So if I run this command, Docker images, and you can see here, there is one image called Jenkins. The ID of the image is this. It's 810 MB in total, but by compression, it is stored as 292 MB file. Okay, this image is downloaded. Now let's run a container out of it. I would say sudo docker run. I'm going to run in this way, and Jenkins/Jenkins. Okay, so Docker run. Run is the command to run a container from an image. Okay. Now these are some options which I'm going to talk about later, but this is important for demonstration because this will allow us to see what is happening. Okay, this and then Jenkins/Jenkins. So what Docker is going to do is it's going to pick up this image and execute and start one instance of the container. Right. So as I mentioned before, you can, when you have an image, you can execute it and then get an application. So that's what I have done. Docker run is executing it. To execute this image to get the container. Now, if I do a Docker PS, come on, do Docker PS, you will see all the containers running. And there is this container with this ID, with this name, and so many other details. This is based on this image Jenkins, and then so many other details, which are important but are not relevant right now. The one thing which I will take from this is 32768. Okay, so it is running this application, running this container, and making it available on port 32768. So now, if I browse to the IP address of this host, this machine, which is this one, this is the IP address, or this is the DNS name. So you can take IP address also. And I will just say go to port 32768. I see Jenkins. Okay, Jenkins is available for me on this host. What did I have to do? I did nothing. I just said Docker run. And now Jenkins is there. There is no requirement for writing any configuration. There is no requirement for installing any dependencies like Java. There was nothing required. I just did it and it worked. So this is how this is how containers work. Okay. So let's recap. Somebody makes container image and makes it available on the registry on Docker Hub. There could be other registries also. And then the customers can download the image using a command called Docker pull, right? Docker pull. With the Docker pull command, an image is downloaded locally. And with the Docker run command, with the Docker run command, very good. With the Docker run command, then we can execute the container of the application. And then we can access it from outside, right? Like I access it here. Is it making sense? All right. So let's get into little bit more detail. Okay. So now a Docker image, right? A Docker image, which is right. So that's it. This is the Docker image with this ID. And this is an image which is downloaded by us. Okay. A Docker image contains a lot of information. It contains a lot of data like binaries and libraries. It contains configurations. And it also contains what to do when a container is run. Okay. So let's look at the container that was running for us. Yeah. So when you do Docker PS, you will see the container that was executing. This is the ID of the container, and it also gives a name to the container. Okay. You can refer to the container by either the ID or the name, both are fine. And it is based on Jenkins/Jenkins. Now, a container is like a process. Okay. A container is like a process. So when a process starts, it has to execute something. Now, the container image has a lot of data. Okay. When container starts, what to execute from that image? So that is defined as a command. Okay. So for this image, for this Jenkins image, the command is defined as this one. This is the command that is being executed. So it is truncated right now. It just shows the initial few characters. But if I say no trunk, then I can see the whole command and the whole output. So this is the container ID, the whole container ID, the Jenkins image, and this is the command. So this is the command which will be executed within the container, and all these files required for the command, user bin, tini, Jenkins sh, that all will be present in the image. Okay. And then there is this information as well, right? These ports. So in this process, Jenkins is a web app, right? So the image has a configuration where it says that when a container will start from this image, an application will be available on port 8080. Okay. Application will be available on port 8080, and that's where you can access the application. But to be able to access the application from outside the host, we have to make sure that it is available to an external port as well. This port is only within the container, but then it is mapped to a port on the host. Now, to understand this in detail, we have to talk a lot about networking, bridge networking, host networking, and all. We don't have time for that, but a brief summary is that this is the port which is mapped to this port on the container. So this port of the host is mapped to this port of the container. Any communication coming to this particular port of the host will land here. Okay, that is why when we executed the run command, we did /-db. Okay, the P portion of the command took care of this port mapping. If I don't give a P, then Jenkins will run, a container will run, but will not be accessible outside the host. It will just run locally. Okay. Now, What happens when it runs the containers? Let's take another example. Let's take an example of an image called Nginx. Okay. I have not downloaded the Nginx image. I have not done a Docker pull Nginx. But I'll just say Docker run Nginx. Now, why am I doing Nginx? Because I know that there is a image called Nginx. See, there is an Nginx image. Okay. Docker has also started this hardened image thing. Let's not get into that, but this one is fine for us. So this is the Nginx image. Okay. Now, I don't always need to download the images in advance. When I say Docker run and give the name of the image, if it is not found locally, it will download as well. You can see it downloaded the image and it started running. You can see some output. And now the cursor is just blinking. I can't do anything here. This is no terminal. It's just an output which I'm seeing from the container. So by default, when you run a container with the Docker run command, it will show the complete execution output, standard output and standard error of the container, of the command that is running in the container. And it will connect to the container's terminal. So we lose the control here. You can see here, if I do Docker run Nginx, I got here, and this is the output. The container is running. But we did not see the output when we did Docker run Jenkins. Right? We did not see this output. Why? Because when we did Docker run Jenkins, now first I'm going to control C it. So I'm going to stop the container now. So when we did Docker run Jenkins, we passed -d as well. -d is for detached mode. So which says do not show me the output of the container, just run it. Send the output to the background. Okay, so Jenkins is also producing a lot of such output, but it is sent in the background. So now, if I do Docker PS, and this is the ID of the container, if I say Docker logs and this ID, you will see the output generated by that container. Right, so this is the output that is generated by that container. So the image has something called as jenkins.war. It is extracting it. It's Java based because it's a war file. And then it installs the plugins, does that, done, 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 done. And it shows the initial configuration, the initial password. And that's it. So it is doing everything within the container. It's just that we suppress the output. Okay. So you can change the behavior of how the container works by passing some options during the initialization of the container, during the run command of the container. If I say Docker run -d Nginx, then Nginx will be started, but I will not see the logs. Let's do a Docker PS. And now I'm going to say logs Nginx. And these are the logs. Okay. So that's how the containers work. It was a very, very brief overview. We can spend a lot of time in understanding how to produce the containers, like around 3 to 4 hours we can spend on this. Then, how to publish them,
and then how to consume them, how to integrate them with Kubernetes and all. So yeah, I will stop here right now and I'll give you guys an opportunity to ask questions and I'll try to answer them as well. How to download image outside of Docker Hub like private registry? Okay, if you have a private registry, well, that's a good question. Each Docker image has a complete information about where it's located, okay, where it is coming from. So a Docker image has a name like this, registry name, okay, slash account name. One second, just 1 second, please. Right. So any container has a name like this, okay, account, or I would say account path and slash, wait, hold on a sec. So complete image, yeah, complete image path colon tag. Okay. So that means that there could be any value for these things in an image. Let's take an example of Jenkins, right? For Jenkins image, what did we do? We did Jenkins slash Jenkins. We just give that Docker pull Jenkins slash Jenkins. Okay. Now we did not provide any tag. We did not provide any registry name or complete image path. What did we provide? We just provide Jenkins. What does that mean? Okay. So if you just provide a name and nothing else, it assumes that it is coming from Docker Hub registry. So it will pull from Docker Hub. By default, it will assume that it is coming from docker.io. So it will prepend docker.io to the name, unless you specify some other registry name. And at the end, it will automatically assume that you want the latest tag. What is a tag? A tag is like a version of an image. So you can have a Jenkins container image, but you can have Jenkins version 0, version 1, version 2. So for that, there will be different versions of the image that is called a tag. Okay. So Docker IO, Jenkins latest. Okay. And we gave Nginx also, right? So we just gave Nginx. So it just assumed docker.io slash Nginx and colon latest. Okay. If you want to pull from some other registry, you can say, for example, in case of AWS Elastic Container Registries, It is something like this, .ecr.aws.com slash some path slash some image colon latest, something like this. So you just have to give a path like this, the full name. And then Docker will understand that it's not coming from docker.io, it's coming from ECR. Okay. Sorry, long answer, but I had to explain many things. Thank you for the question. Best practices for creating, storing images in repos, administration task for maintaining repositories, like what should be our task as admin or end user. You should always be creating images using CI pipelines and using Docker files, and make sure that your images are as small as possible. Okay, so do not have unnecessary data. And we have not talked about it, the how to create the images. But if you already know, then you should use multi-stage builds so that you only have the required data in the images. Okay, so always have multi-stage builds. Also, always scan your images for any vulnerabilities. Okay, any problems with the binaries, any security challenges, you should scan those images. Okay. If web server engine is running in Docker container, does it require an IP address of its own, or it uses IP address of the host? So it will use the IP address of the host if you're running it in Docker. And as I showed, you can use -p for getting a port and then exposing it on that. But in production, we don't use this method. We always deploy on a container cluster like Kubernetes or Docker Swarm, or third-party Kubernetes services like EKS or OpenShift or something, where the IP address is dynamically assigned. You can use the load balancer. Can we extract code from the Docker image? Whatever is in the Docker image can be extracted. Yes. Okay. So for example, let me just quickly show you Docker export. I can use a command called Docker export nginx. Yeah. So if you run a command called Docker save, it's going to save an image as a tarball. So you can see here test.tar, or you can give any extension, and then you can have the complete code here, and then you can browse it. Okay. Assume I have 100 containers. How to patch them? Your application code should be in, of course, in Git, and you should be using CI pipelines to building your container. So as soon as you merge your pull request, you should be creating new versions of the container. Please remember, do not overwrite previous versions of the container. You should always create new version of the container. Okay, so create a new tag of the container so that any customers will not be impacted because you overwrote something. Okay. If multiple containers are running on a host and each container has a memory limit, how does Docker handle memory and contention when the host itself runs out of memory? Docker does not handle that. That is not a problem for Docker. Docker will just start crashing. The containers will start complaining and crashing. Even Kubernetes does not handle that. So it is the responsibility of the infrastructure owners to make sure that there is sufficient amount of resources available. What Docker will do is it will honor the memory limits that we specify. So if you say do not take more than 500 MB for this container, it will not take more than 500 MB. Okay. But beyond that, if you run 100 containers with 500 MB each and you only have 8 GB memory, then it is on you, not on Docker. Assume I have one web app and this web app using MySQL. So what will be the scenario? Can we deploy both web app and DB on a single Docker image? Or I have to create separate images? You have to create separate images. In one Docker image, you can run only one process in one Docker container. So if you have a web app, you will be running that, but then your database should run somewhere else in another container. And that container, you can run it on the same host, or you can run it on a different host as well. Ideally, it should be on a different host so that you don't put all your eggs in a single basket. Any more questions, guys? I don't see any more questions. Okay, how to maintain and clear the Docker registry? Well, that you have to do from the registry itself. Right, so if you have some older images, you can always log into your account and delete the images. Of course, you cannot delete other people's images, right? For example, this Nginx is built by Nginx itself. It's an official Docker image, so you can't delete it. But in your account, you can delete. Okay, so you can clear it up for sure. And that is a good idea to do as well. Yes. All right. Thank you, folks. Okay, one more question. Is Docker image run as regular service? A Docker container? Yeah, you can run the Docker container as a, you cannot natively run a container as a service. That means you cannot assume that the container will come back up when you restart your laptop if you are only using Docker. But if you use Kubernetes or Docker Swarm or any other container orchestration solution, then you can achieve that. Okay. All right, folks. Thank you for your time. It was very nice talking to you. You have the recordings as well. It will be shared with you. And I will meet you some other time. Thank you very much. Right. Please take care and have fun. Bye.